Integrated 3, this is kind of a mini demonstration for lesson 1.2.2. It's about modeling a geometric relationship. It says mathematics can be used to model physical relationships. In this lesson, you will analyze a geometric relationship and look for connections among its multiple representations. You will be given a geometric situation to explore and analyze by gathering and interpreting data. Then you will generalize your findings by creating a mathematical model so that you can make predictions. So that's kind of what we've been learning about so far since school started is why why is math important? How can we use math in the real world to actually model something? So in this problem, we're going to be looking at like a flat net of a box and exploring the height of the box and its relationship with the volume. So in a real world situation, maybe you could imagine that you have a certain amount of cardboard or whatever, and you want to maybe make the box so it fits the most, I don't know, whatever you're shipping, like sand or, it has to have a volume, so marbles or something. You're trying to make the box as big on the inside as you can. You can actually make a mathematical model for that, and you can, instead of like building a whole bunch of boxes and keep putting the marbles in to see how many fit, you can actually just make a math model of it. And so this is something we would have done in class in person, and it would have been probably a lot better, but we're not in person right now, so I'm going to just go through it, and I guess you guys can watch. So it says your team will make several paper boxes using the instructions given below. Based on the physical models, you will then represent the relationship between the height of each box and the volume in multiple ways. Cut a sheet of centimeter grid paper to match the dimensions that your team has been assigned. Then cut the same size square out of each corner and fold the sides up to form a shallow box. And we'll go through all that. So we're supposed to investigate the relationship between the height of the box, which is the input, which we're going to call it X, and its volume, which is the output. Do not use a graphing calculator today. You can use a scientific calculator. So we are eventually going to use a graphing calculator, but at this point we're trying to actually make a physical model. To analyze this relationship, your team will make at least 6 different size boxes. Well, we're going to do the best we can. I'm just going to use this document camera. Begin with 6 equally sized pieces of grid paper and cut to your assigned dimensions. Record your information, including diagrams, a table, and a graph. So let's start out like that. So our dimensions that we're given, I just wanted to keep it very simple. So let's say this is our cardboard that we're going to make a box out of this. It's 10 by, okay, and so we're just that's what we have. And so what we're trying to do is cut the corners out and fold it up so that it actually makes an open box. And so you can imagine this is just that same sheet of paper. I just cut out a 1 by 1 square at each corner. And if I fold it up, I don't think I'll tape it. I'll just fold it up, and you can imagine it makes a little box, a shallow little box. It looks like the lid of a shoebox or something. And I can easily find the volume of this box, because if you remember that since I have these perfect little grid lines on here, I think you can remember that volume is just how many cubes it's made out of. So, and you might also know that it's length times width times height. So I can just say that it's 8 by 6. So it's 6 times 8. This thing would have a volume of 48. So I'm going to record that in a table. Let's get a table. So so the height, what's the height? The height of this first box is just 1, right? So I'm going to write height. And then the volume. What's the volume? We just found out. We folded the box up. We found out that you can create this out of 6 times 8 is 48. Okay, and then we're just going to try. I could actually include on my table 0, 0, because if I had the height 0, then the volume would be 0. It would hold, like if it was marbles or cubes or something you were trying to hold in your box, you would have 0. There wouldn't be anywhere to put anything. So you can imagine that the next sized height I could get is if it were too high. So for it to be too high, I actually have to cut out this corner, this 2 by 2 corner. I hope that makes sense. I can't just cut out 2. I mean, if you guys were in person in your teams, I've done this several times in class, and I've had kids try to cut out, they'll just cut out like maybe these 2, and then they'll try to fold the box up, and they'll find out that it doesn't work out. It'll be like one of the little edges will be way up tall, like one of the sides will be taller than the other side. So that's why we're having to cut out perfect squares. So this one will have a height of 2, and I've already cut one out. I don't know if you can tell. So when I fold this up, I've got a height of 2. Hopefully that makes sense to you. And what is the volume of this? Well, volume is length times width times height. Let's write that down. So it's going to be length 6, width is 4, height is 2. 6 times 4 is 24 times 2. Hey, well that's 48 again. So you can imagine this one and this one, they both hold the same amount of material, whether it be marbles or whatever, you're going to pour into this box. Sand, chocolate, maybe they're chocolate bars or something. Let's try, the next height would be 3. So when I take 3 off the corner, I have to take 3 off both corners. I'm just showing you. So really I'm taking like 9 little cubes, or 9, well I'm taking a 3 by 3 square anyway. Okay, and that's going to make my box a lot taller. It's going to make the height of my box 3. Oh, see. Okay, so I'm going to fold it up. And now this box, what is the volume of this box? Well, it's length times width times height. So let's see, it's 4 times 2 times the height was 3. So 4 times 2 is 8 times 3, that's 24. And then let's see if we can make it even taller. Uh-oh. I don't think I have enough room to make it any taller. I don't know if you noticed this, but if I try to cut out, so this is a this whole part right here, that's a 4 by 4 square, but if I try to cut it out and then I cut out the other one, there's not enough room for it to be a box anymore, if that makes any sense. It's just going to cut all the pieces off and it'll just be a strip. So this is pretty much our table. If you wanted to, well, what I want to do is have you guys go in your teams and see if you can figure out some kind of formula for this. So you have a table. If you want to make a graph, you guys can do that in your teams. You can make a graph. Just graph these 1, 2, 3, 4 points. And then a table, a graph, you don't have an equation. We do have a situation. The situation is that we're trying to make a rectangular box because maybe we want to ship something in it. Okay, so I'll end it there and then we'll let you guys take over.